And we will be recording this webinar to provide afterwards for everyone, in case, folks weren't able to attend. Also, the slides will be provided afterwards for reference. So we'll go ahead and get started with the agenda today. Part 1, we'll go through navigating the New York State declared disasters. Part 2, we'll be going over understanding the benefit cost analysis. Part 3, we'll be going over adding the BCA Toolkit v6.0, the Excel add-in. Part 4, how to start the analysis within the BCA Toolkit. Part 5, some additional resources that you can utilize for your analysis. And part 6, we will have room for a question and answer Q&A session. Part 1, navigating New York State declared disasters. So DHSES has currently 3 funding opportunities available. The first being DR 4814. Current funding available is in the amount of $4,756,434. It is 75-25 cost share, 75% federal, and 25% non-federal match. And the reason why there's an asterisk next to the funding amount is because HMGP funds are based on the estimated total federal assistance, subject to the sliding scale formula that FEMA provides for disaster recovery for each major disaster declaration. Therefore, should that funding amount be modified, DHSES will be sure to inform all sub-applicants. DR 4825, the funding available for this is $6,200,052, also a 75-25 cost share. DR 4839, funding available in the amount of $5,411,815, and this is also a 75-25 cost share. Some key dates and deadlines for these unified disasters is the application deadline will be Wednesday, April 30th, 2025 by 5 p.m. Eastern, and submission will be via email to hazardmitigation@dhses.ny.gov. Just a little background info on the Hazard Mitigation Grant Program. The Federal Emergency Management Agency, FEMA, provides the Hazard Mitigation Assistance HMA program to provide funding after the state receives a presidential declaration. So anytime the president declares a disaster, through Section 404 of the Stafford Act, funding is authorized for the Hazard Mitigation Grant Program, HMGP. This funding supports long-term hazard mitigation measures that enhance the state's resiliency, avoid loss of life, increase sustainability, and reduce damages to property and infrastructure. Hazard mitigation can be defined as any action taken to reduce the long-term risk to people and/or property from natural hazards and their effect. Below, we've listed the link to access the 2024 HMA Program and Policy Guide. This is the most updated program policy guide, and this will be used for all upcoming funding opportunities. Pre-calculated benefits. So FEMA has published various benefit cost efficiencies to offer predetermined values for cost effectiveness. The goal is to try to streamline the BCA hurdle and make it a bit easier to get the foot in the door and show the project is cost effective. So using pre-calculated benefits eliminates the requirement for applicants to conduct a full BCA for eligible projects through the FEMA BCA Toolkit. Pre-calculated benefits are not meant to influence actual project expenses or function as detailed project cost estimates. Individual project cost estimates should be derived from industry standards, vendor assessments, and/or other approved sources. So basically what that is implying is, for example, if the pre-calculated benefit for an elevation project in a special flood hazard area is approximately $355,000, if your cost estimate is exactly 355,000 to be exactly equal to the amount of pre-calculated benefits, that kind of gives away that, is that accurate? Was this just put there to show that the project is cost effective based on the amount of benefits? What's important is that, it's derived from industry standards. Just because you have 355K in pre-calculated benefits doesn't mean that, that should be the cost of the project, because the cost of the project could be far less than that. Some of the updated pre-calculated benefit values, specifically for an acquisition project, buying out a property within the special flood hazard area. If the project cost, this includes the legal fees, demolition, site restoration, altogether is under $775,411 per structure, and it's located in the special flood hazard area, no full BCA is required. Similarly, for elevation projects, if you're elevating a structure in the special flood hazard area and the cost for all activities is less than $355,522 per structure, then no BCA is required. And hospital generators. Now, if a hospital generator has an emergency department and the generator mitigation action is a standalone solution, meaning it's not contingent upon other projects or other ongoing improvements. For example, that a department needs to be built for this generator project to be implemented, that type of thing. That's what's implied by standalone solution. And then based on the area that the hospital is located, FEMA has assigned these predetermined benefit values for building gross square footage. So if a hospital is located in an urban area, the pre-calculated benefit is $6.95 per building gross square footage. And if the hospital is in a rural area, then that benefit value is $12.62 per building gross square footage. So you'd multiply the building gross square footage by the value, depending on if you're in an urban or a rural area, and that would provide you a pre-calculated benefit value. Another policy that FEMA has released fairly recently is the allowing a BCA narrative for projects under $1 million. So for projects with a total cost of less than 1 million, sub-applicants may submit a cost-effective narrative that FEMA will use to validate a project cost effectiveness and estimate a BCR. So they'll try to run a benefit cost analysis on their end, depending on the information provided in the narrative. Some of the key prompts provided by FEMA to include in the narrative include how often the hazard being mitigated occurs, how many people benefit from the proposed mitigation project, and how is this number determined, what structures, infrastructure, and building contents, if any, would be damaged should the project not be implemented. So in case there was a do nothing alternative, what is the risk? You need to paint that picture and kind of outline what the avoided damages, avoided losses would be if, this project was not implemented. What public services, including public safety, transportations, and utilities and/or businesses, if any, would lose function during future hazard events if the project is not implemented? And lastly, are there any additional benefits directly attributable to the proposed project that are not captured elsewhere in the cost effectiveness narrative? So these prompts, seem pretty straightforward, and you could probably answer all these questions within a brief paragraph. However, what's key is making sure that you can provide supporting documents to support any values used. So when you say, how many people are benefiting, how did you arrive at that number? Did you look at the census tract data to see, what the population is for that area? Things like that. Any supporting documents you can use to show that where these values were sourced from. That always helps make it easier and able to withstand, FEMA review. Now we'll go into introduction to the benefit cost analysis. Again, the Robert T. Stafford Disaster Relief and Emergency Act, also commonly known as just the Stafford Act, requires all mitigation projects to have a cost effectiveness determination as a basic eligibility requirement. This law is carried out under the 44 Code of Federal Regulations, CFR, Emergency Management and Assistance, and specifically 206.434C5, which states that projects must be cost effective to be eligible for the Hazard Mitigation Grant Program. The FEMA BCA Toolkit 6.0. This is currently the most latest version of the BCA calculator, and to ensure the project is cost effective, the applicant and sub-applicant must use FEMA approved methodology and the supplemental guidance provided for the BCA Toolkit B6.0. Cost effectiveness. Project is cost effective when the benefit cost ratio, BCR, is 1.0 or greater, indicating that the benefits of the prospective hazard mitigation project are sufficient to justify the cost. And in past analysis, it has shown that every dollar spent on mitigation has saved $6 at minimum for future drawdowns to the disaster relief fund. Understanding the benefit cost analysis, the BCA. Benefit cost analysis, BCA, is the process of weighing the benefits of a particular action against its costs. A benefit cost ratio, BCR, is equal to the benefits divided by the total project cost. And the BCR is, if it's greater or equal than 1.0, the project is deemed cost effective. Typically, you want it to be a little bit higher than 1.0. The minimum requirement is 1.0, but over the course of the project, if there are any cost overruns or the price of materials or labor increases, you need some wiggle room, because if the project cost increases, you still have to meet all eligibility requirements, and the project needs to still remain cost effective to continue to be eligible for HMA funding. The BCA compares the conditions before and after the mitigation activity is implemented. This tool is utilized to calculate risk reduction in terms of losses avoided. Risk is the severity of the event and its likelihood. Losses are calculated based on the size, the recurrence interval, or frequency of the event, and are determined based on historical costs, damages, calculations from engineering analyses, and estimated losses. Some questions to ask before starting a benefit cost analysis include: what is the cost of the project? Once you can determine that, then you have a baseline to be able to conduct a BCA and understand how many benefits are needed to show that the project is cost effective. In addition to what the cost of implementing the project is, how much will it cost to upkeep and maintain this project to its standard level of effectiveness? For example, if there is a flood wall being built, what will be the maintenance to ensure that it continues providing protection for that 100-year level flood, or whatever this level of effectiveness, level of protection it is designed to provide. And if that maintenance cost is a 5-year plan, you would divide that by 5 to understand what the annual maintenance cost is, because that is one of the data fields needed within the BCA calculator. What natural hazards is your project addressing? Is it, coastal flooding? Is it riverine flooding? Is it a landslide hazard? Is it severe winds? How often does this hazard occur? Is this something that happens, frequently throughout the year? Is this something that occurs every 10 years, 20 years? What damages is the community experiencing due to this hazard? Are there roads impassable? Residents aren't able to use, and they have to, use detours. What damages is the community experiencing due to this hazard? And how much damage will be prevented by implementing this project? If you build a $10 million bridge, are the benefits there? Are there amount of population that will be benefiting from this HMGP project? These type of questions are important to ask before starting the BCA and understanding, where your benefits will be coming from. Natural hazards, determining frequency. Although we cannot predict when hazards will occur, we can estimate how likely they are based on historical events, hazard data, or specific hazard analyses, such as the hydrologic and hydraulic study, also commonly known as an H&H. The frequency of a hazard occurring can be represented through a recurrence interval. Now, the recurrence interval is not to be confused with how frequently the event happens. For example, you may have storm event that's impacting your community every 2 years, but that wouldn't necessarily imply that the recurrence interval is two. The severity of the storm, it could be that you're having a 50-year storm more frequently, and that would be the actual recurrence interval. So determining the recurrence interval is complex and requires an engineer's assessment to analyze historical outage data, system vulnerabilities, and risk factors specific to the site. Since this is a key input for the BCA, an engineer's evaluation is necessary to establish a defensible recurrence interval for modeling avoided damages accurately. When you are using historical damages, the BCA calculator will auto-calculate the recurrence interval for you as long as you provide a minimum of 3 past events. However, you still would need to be able to calculate what the recurrence interval is of the project after being implemented. Once the project is implemented, what is the residual risk that remains? Like, if there is another 50-year storm or 200-year storm, now that the project is implemented, how much of that risk still exists? Is it 5% of the damages that originally the town was experiencing, et cetera? Natural hazards, determining damages. Some of the key components for that are loss of service, physical damages, avoided injuries, loss of life, emergency management costs, ecosystem service benefits, and displacement costs. Loss of function, loss of service. Now, this is interruption to critical services, roads, bridges, and utilities caused by a natural hazard event. Benefits can be quantified by the value of the function and length of the interruption. And here we have a picture of a hospital that experienced flooding, and then employees needed to get together and um, help take care of the flood at hand. And this was a interruption to the service that they provide normally. Critical facilities. Benefits are calculated based on mitigation loss of service by allowing police stations, fire stations, hospitals, and other facilities to stay open or at least reduce their downtime. So the BCA toolkit auto calculates the value of service per day for critical facilities based on the inputs for following questions and some additional prompts such as, population served by the facility, what's the distance to the closest alternative facility, and then depending on the type of facility, for example, if it's a fire station, do they provide EMS services? Yes or no, and then the toolkit will add a default value if they do or do not provide that. For other critical facilities, that aren't typically police stations, fire stations, hospitals, but are critical for the community. For that case, an annual operating budget includes, staffing cost, operating cost, and then the duration of time that the service is lost to required to quantify the benefits. Optional damages could also be loss of revenue. So these are all inputs that, you'll be able to put in the for mitigation damages section. Roads and bridges. Benefits are calculated depending on increased time and distance of detours needed when a road/bridge is lost or closed. Utilities, service providers, benefits are calculated based on FEMA value of service, dollar amount per person per day, multiplied by the number of customers served and the duration of service loss. The BCA toolkit uses standard values for electrical, potable water, and wastewater services. Some of the standard values are listed here for reference. Now we'll move into some of the information needed to start the benefit cost analysis in the toolkit. We'll go through the prompts or data fields and, where can you get that information from? Project location, property location. For each project structure, you'll either need to provide the specific address, or if you have the coordinates, you can also enter in the lat and long. Where can you get this information? This information can be obtained from online mapping services, Google Maps, ERTS, can also be found in title documents from the local building inspector, local tax assessor's office. Property structure type. This description / classification of the structure would be as, is it a residential building, non-residential building, critical facility building, utility, road / bridge. And you can get this information from photos of the property, the scope of work description, and then furthermore, if you have drawings, that's helpful because then you'll know exactly what the structure is and what type of materials, et cetera, were used if you needed to retrofit the facility. Hazard type, description of the natural hazard the project intends to address. And where can you get this information? Historical accounts of past damages and hazards causing them. This could be information obtained from the project manager, project engineer, planner, or other representative familiar with the proposed project. Mitigation action type. This describes the specific mitigation project being considered, for example, floodplain and stream restoration, elevation acquisition, or infrastructure failure. Where can this information be obtained? From the detailed scope of work description. This is also information that can be obtained from the project manager, engineer, planner, or other representative familiar with proposed project. And a great resource is the BCA help menu, which has detailed definitions for each mitigation action type description. One of the key components for strong benefit cost analysis is providing supporting documents. So we're going to go through some of the general types of projects that we see and what are supporting documents that you can obtain or provide to quantify possible benefits or proof of avoidable damages. So for acquisition, elevation, and floodproofing projects, some of these examples include cost of previous repairs and damages from flooding, invoices, things like that. Elevation certificate that will have a lot of the information on the, base flood elevation, the lowest floor elevation, et cetera. Any insurance claims from the past, receipts for work completed, materials and volunteer hours associated with repairing flood damage, engineer's assessment of damage to the building, an engineer's mitigation proposal, an estimate of reduced floodwater elevation in the building, services provided by the facility if it is a commercial building, and effects of flood events on business in case there's any loss of revenue. Those would be some optional damages that could be included. Next up, we'll talk about the drainage improvement and culvert upgrade type of project. For this, some supporting documentation examples would include, detour information on a road closure due to flooding, cost of emergency measures taken in response to flooding, if there's any past project worksheets available from public assistance for that location or facility, any town pay stubs, timesheets for work related to damages from past flooding, traffic count on road for proposed mitigation project. This would help support, how many individuals are using this road on a daily basis, because these are the amount of folks that would be impacted should the road be impassable. And also can provide an official town statement of materials, labor, equipment used for work related to damages from past flooding. Next up is the generator project type. For this, power outage history at the critical facility is a great supporting document. This can be obtained from the electrical service provider. If this facility runs, serves as an emergency shelter, what is the cost of running an emergency shelter for one day? Based on that cost, you can multiply that by, 365 to figure out what an annual operating budget would be for this other type of critical facility. Are there emergency medical services provided by the facility? What is the population served by this facility? And what is the distance to the nearest critical facility in the event power is lost? For example, there's two fire stations within the town, and if one were impacted, how far is the second fire station that would be able to be activated and serve the population in need? Here, we wanted to just provide an example of a cost estimate. So building a cost estimate at the start of the project is critical. Knowing all the costs associated, it won't, for example, for a generator project, it's not going to be just the quote for the generator. It will also need to include other items. A lot of times FEMA, depending on what type of facility is and where the facility is located, the generator may need to be elevated to a certain elevation. So there might need to be a concrete pad. FEMA may also require that there's a fence enclosure for the generator. So all of these should be priced out at the start of the project to get a good understanding of what the project is going to cost. And that way, we're requesting the correct amount of funds at the start of the project. And here you'll see the example, 60 kilowatt generator, an automatic transfer switch, put an example of unit price 45,000 for one unit, concrete pad, put an estimated cost of 15,000, and fence enclosure for the generator 5,000, all totaling 65,000. Supporting documentation examples. So if you are claiming that there is a road that's impassable and that, there's a 20-minute detour with 15 miles added on, then, just a printout of the detour, you can use Google Maps, and drag the points from the road that's impassable, and, just kind of support your claim for how long the detour is. Part 3, BCA Toolkit version 6.0 Excel add-in. Again, some of the concepts, general concept for BCA, FEMA requires the BCA to validate its cost effectiveness. The BCR is 1.0 or greater, and the project is considered cost effective. And to ensure the project is cost effective, applicants and sub-applicants must use FEMA approved methodologies and supplemental guidance for the BCA Toolkit V6.0. Getting started with the Toolkit 6.0 version, first you'd like to go to this web link posted here for FEMA.gov grants guidance tools benefit cost analysis. From here, you'll be able to download the BCA Toolkit version 6.0. It'll be an Excel template. Once you get the file, that Excel file downloaded, you'll want to go ahead and open it. And it may just look like a blank spreadsheet at first glance, but there's a few, preliminary steps that you need to do to access the toolkit. So for that, you need to go into the Insert tab at the top left, right next to the Home tab, and click on Insert. Once you click on Insert, you will go into the Add-ins section and click on Get Add-ins. This will allow you to access the Microsoft Store. From there, in the Microsoft Store, you will enter BCA into the search bar, and the search results should be FEMA Benefit Cost Analysis Calculator. We'll go ahead and click the green add-in button next to it. Should you agree with all the license terms and privacy policy, go ahead and click Continue. And then if you see a green dialog box saying Get Started with your FEMA BCA add-in, and you'll see the BCA Toolkit icon at the top right, That means you have successfully added it into your Excel template. So that's one of the precursor steps needed. And then once you click on that add-in, it'll open a side window, and from there you'll be able to start your analysis. And we'll cover that in part 4, BCA Toolkit version 6.0, starting the analysis. So now that we have added in the BCA Toolkit 6.0 into your Excel, you'll go ahead and click the ribbon, and it'll open up a side window named FEMA BCA Calculator. You'll click on the blue Open Calculator button to begin the BCA, and that'll open up a new window for you. Within that, you'll go ahead and click plus Add Project on the top left, and that will allow you to start entering in key data points for your analysis. Some of the few initial inputs will be project title. You'll input the same title used in the sub application for consistency. Property location, it's important to use the accurate project address, or if you have the specific GPS coordinates, you can enter those in. For property structure type, there is a drop-down selection. From there, you can select critical facility, utility, roads and bridges, whether it's a residential, non-residential building, and other if it doesn't fit into any of those categories. Hazard type, this will be another drop-down selection for the primary hazard being mitigated. And then mitigation action type, this drop-down selection, you'll select the action type that best relates to your proposed scope. Another great resource that we want to emphasize is the eye icon, the help button. This is a great resource for going over standard values accepted by FEMA and also defining all the terms and data fields used within the toolkit. Where possible, default values have been populated in the toolkit, and you can switch the toggle outline in red to no if you needed to enter in a custom value based on your analysis. However, make sure to always provide a comment and documentation if you do not use the default value provided. If you're using the default value, there's no justification needed for it. But if you are changing the default value to a custom value, then comments and documentation are provided. And in terms of comments, if you'll see in the box right next to enter the project useful life 19, and then all the way to the right, you see that little box with 3 lines and a little plus sign. That's the box you would right click to enter in your comment and save it. And then when you print out your BCA report, it'll have each value, and then under it, it'll have your comment. There you can, reference the source documentation to justify where the information is coming from. Next up, we'll be going over the damage and frequency relationship.
We do have one question. If you don't mind addressing it real quick, Rob. It's not in the chat. I have it right here.
Sure.
The question asks, is cost benefit analysis needed for a mapping and hydrology study project and or for planning projects in general?
Great question. No, if it's a scoping project or just a design project, no benefit cost analysis is needed. If it was a construction project, for that, a benefit cost analysis is needed. And if it was a phase project where you're going to be doing design first, preliminary BCA is needed. And then once design is completed, you would submit those phase 1 deliverables back to FEMA with an updated BCA. And for that, the BCA would need it. But if you're just pursuing a scoping project, just a study, no full BCA is needed for that. Great question. And back to the damage and frequency relationships, the 3 types provided in the toolkit are model damages, historical damages, and professional expected damages. Model damages, you'll select this option to perform the analysis on the property regardless of past damage history. The BCA results for the selected hazard will be modeled based on the inputs provided. So for example, if you were doing a green infrastructure project and you're planning to plant some urban trees, based on the amount of trees you will be planting and the location, you'll enter that in, and the BCA toolkit will automatically, model how many benefits are available for the project. So that's a streamlined method. But it is not available for all mitigation actions. There are very few mitigation actions it is available for. So if it is available for your mitigation action, you can use that. Historical damages, you'll select this option if historic damages and losses and dates and years are available. So if you have good supporting documents, receipts, utility power outage reports, claims, repair records, data from state local agencies, newspaper sightings, FEMA project worksheets, these are all good documents to utilize for a historical damages module. And then last but not least, the professional expected damages module. You would select this option if the scientific data would show how much damage would result if a given event were to occur. So the catastrophic event hasn't occurred, but if this event were to occur, these are what the expected damages would look like. And documentation could include engineering reports, technical studies, etc. Documentation must be provided for all damages. One instance for professional expected damage, it doesn't necessarily follow this, is the professional expected damages module for a generator project. FEMA has recently released default impact days and recurrence intervals to help reduce the burden of obtaining all that scientific data. So that is one module that you wouldn't need an engineering report to support the expected damages because those are default values provided by FEMA. Next up, we'll go into the damage frequency assessment section. Year of analysis conducted. This will typically just be the current calendar year that you're when you're utilizing the toolkit, and it'll update automatically. Year property was built. This is when the asset being mitigated was built, building, utility, roadways, bridges, other assets, etc. And then the analysis duration, the grayed out box. This is all auto-calculated from the difference between the above inputs. Therefore, if you were doing a historical damages analysis, since this property was built in 1952, you can claim any damage events that have happened over the last 72 years. But of course, if the property was built 3 years ago, you wouldn't be able to claim any damages that occurred prior to the property being built. Part 5, BCA additional resources. Here, we're going to go through some key links that can be utilized, and these will all be provided in the webinar slides post-webinar as well. We have FEMA's 2009 BCA reference guide, the link for FEMA's 2011 supplement to the BCA reference guide, BCA Toolkit 6.0 release notes that were provided in July 2020, and FEMA's BCA Toolkit 6.0 installation instructions. Dishes has also posted BCA Toolkit 6.0 installation instructions on the Dishes HM website, so also refer to that link as well. Furthermore, we have FEMA's 2019 BCA training materials, E-L0276 course. FEMA's how to complete a streamlined BCA page, including updates to the pre-calculated benefit values. FEMA's Flood Map Service Center, MSC. This is great for pulling any flood insurance rate maps, also known as FERMETs. This can be used to show, where the property structure is located in reference to the special flood hazard area. And then FEMA Resiliency Analysis and Planning Tool, also known as the RAP tool. This is a GIS tool, and you can use a lot of layers within this tool, to show urban area, show rural area, show nearest facilities. So there's tons of layers that you can use within that. United States Census Bureau Tiger Web. This is another GIS tool. This can be used for classifying, if hospitals are in urban or rural area. That is one of the requirements for using that pre-calculated benefit threshold that we discussed earlier. Here's some additional resources you can use for calculating recurrence intervals. We have the American Society of Civil Engineers data for hurricane wind speed and seismic data by location. We have the National Weather Service Precipitation Frequency Data Server, NOAA National Centers for Environmental Information Storm Events Database, U.S. Geological Survey stream gauge data at water.data.usgs.gov, and this can be used to extrapolate frequency information for flood events. You can also see section 2.1.2 from the supplement to the BCA reference guide, and you can read more on the topic from USGS regarding flood recurrence intervals and 100-year floods with the link posted here. And with that, we'd like to thank everyone for joining us today for this BCA 101 webinar. DHSES has a team available and ready to provide technical assistance with application development, assistance with the benefit cost analysis, and assistance to applicants who are not familiar with the FEMA HMGP process. Any requests, please forward them on to the email inbox hazardmitigation@dhses.ny.gov, and we'll make sure to get you the support you need.